Hello, my name is Phil Sewell. I'm the Strategic Security Architect for Voltage Data Privacy and Protection at CyberRes, a Micro Focus line of business. I wish I could be there in sunny Florida for the Health ISAC Summit, but like many of you, I am working from home at this time. I live in Toronto, Canada, and we still have pandemic restrictions in place at this time. So I hope you are all well. In today's presentation, I'm going to be talking about preserving the privacy of health data in the age of cloud analytics. So why are we here today? This slide is showing a variety of enterprise data trends that we are seeing in the marketplace today from talking to our customers. We are seeing a continual move to monetize more and more data and of course in health space. That means patient data, insurance data, health data of all kinds, and they're doing this and there's a move to more cost-effective data analytic platforms from more traditional relational databases, on-premise data warehouses, to more agile, more cost-effective platforms, mostly on the cloud today. We've been talking to customers for some time about obviously protecting their most sensitive data from a data breach. The question is, if a breach was to happen, what would be the associated costs of that? But really there is a recognition today that it's not a matter of if a breach will happen. It's a matter of really when a breach will happen, and how companies are have to prepare themselves to become more resilient, more cyber resilient in the face of advanced types of attacks on their data, and doing all that they can to protect that data with the most modern capabilities in the market available to them. So there's this move to a term coined by IDC called cyber resilience. So we have been helping customers protect their most sensitive data, their crown jewels, for many times. The point we're making here is this is a move or a recognition that we should be protecting the individual attributes that are most sensitive to our organization. There is not a lot to be gained in encrypting entire operating systems or file systems and databases. It's much more effective if you can narrow your focus into the individual attributes. In today's kind of pandemic times around all things COVID-19, we're seeing, of course, a huge amount of the workforce working from home, and that is creating ever more replication of data, and a lot of that data being transported in and out of the cloud. So we're getting a compounding effect of the amount of data at risk. If we look at some of the numbers from Ponemon Institute, these numbers are from 2020. The cause for concern here is, of course, the cost of these breaches. This is just one number of $3.86 million cost of a breach on average. But there is many effects of these damaging breaches, from reputational risk to basically risks of the entire business. When it comes to the cloud today, most of the customers we talk with are not committing to one single cloud provider, and they're not doing everything in the cloud yet. So there's a mix here. There's a hybrid IT sense today, that there are needs for on-premise data analytics systems, as well as moving some of that to the cloud, but not just one cloud provider, multiple cloud providers. So we're truly seeing a hybrid tone when it comes to the cloud today. And of course, wrapping all this up, centered around data, is the ongoing expansion of data privacy regulations worldwide today. So, of course, those fines are becoming more real today, whether it's GDPR or CCPA in the United States. Those are real dollars. They're impacting companies today worldwide. So what capabilities should be part of a data privacy and protection program? This is how we see this space today. And it's really kind of part of a larger data governance program. It should be recognized that we should offer and require capabilities for data discovery, understanding what sensitive data we have and where is that data. Basing a data governance and data privacy program on a platform for data discovery, an enterprise class product for data discovery for both unstructured and structured data, it is critical to the success of these initiatives. So once we discover that data, we need to understand what risk does it pose. So we need to be able to analyze data very accurately to minimize those false positives. We could even add in identity governance to further kind of enhance the risk assessment of the data and who has access to that data. Then we move around to data protection, right? There's a variety of ways to protect data, innovative ways to protect data in a consistent, persistent end-to-end fashion. Some of this is for unstructured data in file form, where we want to make that as easy as possible on the end users. And we have on the structured side basically innovations around format preserving data protection technologies like FPE, format preserving encryption and tokenization. We want to make sure that data is protected early, protected once, and that protection remains with the data as that data is transported and stored in various places around the network. And let's not forget that some of this data does need to be shared with external parties, third-party, trusted parties. So we have to consider those technologies as well. So putting that all in place, then we have to monitor the use of these technologies. We can combine the event type of logging available from these discrete systems into centralized logging systems, as well as user and entity behavioral analytics, UEBA systems that can truly enhance real-time risk assessment of who has access to what data, potentially who has requested access to the encryption keys, for instance, of a particular piece of data at any one point in time, and is that abnormal for their behavior. So rounding this out, we shouldn't lose sight of the opportunity to minimize our data footprint, minimize that attack surface. So we look at technologies that can identify redundant, obsolete, or trivial data and get rid of that data instead of keeping it around and increasing that risk. We may look at retiring applications and databases. So all of these things come into play centered around data that helps us with the problems of managing data privacy and protecting that privacy in a ongoing operational state. When it comes to protecting data, as I mentioned earlier, there is definitely a better understanding today of protecting data much more effectively at the field level. And we need a variety of new innovations to make this easier for implementation and easier for usability. We call these technologies format preserving data protection technologies. They are things like tokenization, pseudonymization, and format preserving encryption algorithms like FF1. Here's an example of this. Where we have an individual, Leslie Roberts, with a social security number, date of birth, and a credit card number. And when we protect using one of these technologies, we get length and data type preserving values. We get randomized first name and last name. We get a randomized 9 digits of a social security number. We get a date of birth that has been protected to another date, but it is a valid date. Now, this is kind of important when it comes to making sure that a protected date, in this case, does not break any application functionality. So we can do that with some of the advanced data protection characteristics, formatting characteristics. And in this case, the last number you may not be able to tell, but we are preserving leading 6 digits and trailing 4 digits. And actually with the social security number, you can see that we are preserving the trailing 4 digits to extend the usability of this data, both for the social security number and the credit card number. But the credit card number, you won't be able to do it unless you're a math genius, but that number is actually not a valid credit card number because we have reversed the checksum digit checking on that credit card. So it is not a valid credit card, although it does look like a valid 16-digit credit card number. So let's look at a second record to demonstrate something very important to these types of format preserving data-centric field level data protection technologies. So this person's last name happens to be the same as Leslie. This person is David Roberts. The social security number looks quite similar. It's only off by 1 digit. The date of birth is the same, and the credit card is a different value here. So what happens when we protect this data? As perhaps you can anticipate, that the last name is actually exactly the same as the first record. So this is really showing the deterministic nature of these types of technologies. The social security number, although it was only off by 1 digit and 1 digit of the trailing 4 that we are preserving, it didn't matter in this case. We are still getting a completely different 9 digits for the protected social security number. So that demonstrates something special there in terms of making sure that these algorithms do not leak any information that is private. The date of birth is actually protected to exactly the same value as the first record. So all of this deterministic behavior of these technologies help with us in terms of searchability, and in the world of analytics, any joins across tables based on any of these values, and social security number is a common value that we see in real world systems that uniquely identify individuals. If we actually protect those social security numbers across multiple tables, in the same way we are preserving the referential integrity of the data set, as well as just the length and data type. So all of this is really to protect ourselves really from the most modern damaging attacks today that happen through the application layer, rather than more traditional forms of protection like encrypting an entire operating system or file system or the database. These data-centric field-level technologies are much more appropriate for today's modern attack vectors. And it helps us basically preserve the privacy of these data attributes, as well as preserving the analytic value of this data. So here's an example of a real customer of ours, a health insurer in the United States. And this story goes way back to 2014. I was working with this customer, and they were one of the first customers I had seen at scale using Hadoop at this point in time, a big data platform on-premise. We're talking here about 14 million dental members, 13 million pharmacy members, 30 million group insurance members, a huge amount of data in this system. And I recall the VP of Analytics banging on the door saying, you know, when can we get access to this environment? Because we want to start enabling more and more analytics on this data to obviously improve the health service to our users, but also stopping fraud in the system, and opening up this environment to a much wider audience. They actually called it a hackathon, where they could really kind of open up the innovative ideas of a much larger audience if they could protect the data properly. So they were having to comply with HIPAA and high-tech regulations and PCI as well, enterprise-wide. They started with protecting social security numbers. As I said earlier, that's a very common piece of data that we find in many health systems today, pharmacy systems, insurance systems. And if we can rid ourselves of real social security numbers, then we can go a long way from protecting the damage caused by a breach of that type of data. So many customers, like this customer, have to start somewhere. In this case, they started with their high-risk big data Hadoop system and applied format preserving technologies to protect certain attributes in that data set. So when customers are ready to adopt a data-centric approach more widely, a center of excellence should really be put in place. Okay, the earlier example of Hadoop, many customers start small, and initial projects can come to fruition very quickly, as quick as 8 weeks in that earlier customer example. But as people learn from the use of data-centric technologies, and enabling these the value of analytics in this new way of protecting the data, they can definitely adopt this approach more widely for the entire enterprise. Okay, so when that is done, it does require a good amount of organization to bring together multiple stakeholders from across the business, multiple disciplines and domains, in an effort to truly realize data privacy and protection at the enterprise level. So that could be the data privacy office, security, of course, IT, compliance, risk, data governance. Now, when it comes to the tools that will be applied to this, I've shown you some of the advanced technologies to enable this, but there's many parts to this, and there could be a situation here where no one vendor can provide all of the pieces to a true data privacy and protection platform. So, of course, it is built on some very strong capabilities like data discovery, data protection, but many times we will be using a combination of tools that integrate well together, and with a combination of professional services from the software vendors, with consulting and integration partners, we can build out a true delivery and a center of excellence to realize the promise of data privacy and protection at the enterprise level. When it comes to privacy, there is a saying that we can't really have privacy without security. So, of course, security is critical to this, but there's many parts of privacy that we can enable through a variety of technologies. All of these customers that you see represented here in point form are all responsible for protecting health data privacy, and they are all using format preserving data protection technologies to enable powerful data analytics in a variety of platforms. The first example on the left there is a classic example of a customer that started somewhere very different. They started in the world of payments and protecting some of their payments point-to-point and tokenization of credit card data. But they truly saw the vision of adopting a data-centric data protection platform, and that enabled them to start protecting PII for their consumers, as well as actually their employees, and do this in the latest cloud environments. In their case, it's Azure. So someone that's truly in a hybrid IT environment that demands a holistic approach to data privacy. The example in the center is just a revisit of the one I presented a few slides ago, but I just wanted to give you an update here that this is a classic customer that started with Hadoop back in 2014. Many customers around that time were using products like Teradata as well, and many of these customers are moving to these new shared environments. In this case, Google BigQuery and Snowflake, for instance. So we are enabling these customers to make that move and exist and do all these things truly in a hybrid world. The last example just shows, again, a mix of environments here from this customer is still running their analytics on Teradata on-premise, but they're starting to do some of the testing in the cloud, and obviously they plan to move in that direction in the future. This is an example, a data flow, for how data comes into a data analytics platform and how it's consumed in that case. In this example, we're talking about Snowflake. That's a cloud data warehouse run in the cloud. But as you can see from this diagram, starting on the left-hand side, there's multiple paths that data can take to arrive into this environment, to be ingested into this environment. One beautiful example here is if we are helping a customer protect this data at its source, then that data can flow into the cloud, into Snowflake in this case, without any further changes. We don't need to re-encrypt this data. We don't have to put that data at risk. It's already protected. Let's bring that data in as is into the platform. Other places, of course, there will be lots of new data that needs to be protected, and we have choices on whether we protect that data again at the field level on-premise, or we do it upon arrival into the cloud. And we may even combine discovery and risk analysis technologies into the actual movement of the data. Now on the right hand side, we're seeing here the classic story of the majority of users being able to access that data in its protected form and continue to do a wide variety of analytic operations without requiring any access to the underlying original real data. But we know that in many cases that re-identification of that data will be required for a smaller number of privileged users. And that, of course, can be enabled in a variety of mechanisms. In this case, it's enabled through the latest functions as a service operating in the cloud, such as AWS Lambda and Azure Functions. As we often say, it's all about the data. So we need to spend time with the business user, understand their requirements, their data, and then apply the appropriate levels of protection at the field level that makes sense. So some attributes, we can clearly name them as identifying attributes and truly persistently protect them with these data protection technologies, as I've previously shown, and the example of our insurance company there that took an approach of protecting those social security numbers in a persistent fashion, getting rid of them completely from the analytics environment and replacing them with randomized social security numbers. That's an easy example of these identifying attributes. Now, when it comes to quasi-identifying attributes, date of birth is a classic example here. So we have to be a little careful. Many of our customers do choose to encrypt date of birth because it creates a certain amount of toxicity if it exists in the clear alongside other quasi-identifying attributes. So we just have to realize that if we do protect it, there will be certain consequences of doing that, and there's always a trade-off. So we have to think about how this data is, the access to the data is controlled. Is this data going to be shared publicly, for instance? Then the kind of assessment we're doing here has to be taken a little bit more seriously. We may have to trade off a little bit of performance with security. So the clear thing here, though, is that there's a huge amount of data in these environments that we can leave in the clear if we do the right job of protecting the identifying and quasi-identifying attributes properly. There is a lot of value-based attributes that by themselves don't reveal any private parts of the data set, of the individuals concerned in the data set. So leaving those in the clear allows us to perform a huge amount of analytics without any additional cost of re-identification of these other types of attributes. So here's an example I'm using here with fabricated health data to demonstrate some of the things I've explained in this presentation today. So here we have individuals, patients, and we have associated claim information, test information, insurance information, and all this data today, like many cases in the real world, sadly, is exposed and not protected at rest in the databases both on-premise and the cloud today. So what we should recognize here that certain amounts of data are related by potentially identifying attributes like a national ID or social security number, like this example. So if we were to apply a simple masking type of exercise on this data, it would look nice and protected and removing a lot of the private data. But what we've done is break the referential integrity. We've lost value in the data if we take this approach on protecting the data with a crude kind of masking mechanism. So instead, what we do is apply new forms of data protection that preserve the format, are deterministic, and operate at the field level. So we've applied a few of them here, partial examples, and also leaving the actual year of date in the clear, which can definitely help. Instead of revealing the real date of birth, year of birth can adequately stand in and help with the analytic value of the data. So if we now apply the same data protection approach to the related tables, what we're seeing here, by the deterministic nature of these types of algorithms, that social security number has been changed, but it's been changed consistently. So all the values of claim, insurance, and test information are still like they were, preserved for analytic value. So this is ultimately what we mean by enabling analytics on protected data. These examples that show patients with test scores higher than 35 can all be done without any decryption required of the dataset. We can do counting groups by years, by test year, for instance. Again, we don't need to even join information. We don't need to do any re-identification, detokenization, decryption of this data at all. We can do costing information. In this case, we may have to join tables, but those joins will function as you would expect. Then the last example is saying, well, if I do need the exact zip codes that are protected, because we're worried about the privacy of the individuals in this data set, then sure, we can reveal the real zip codes associated with these individuals, and that is available to privileged users, and we can allow that re-identification, that decryption, that detokenization to occur as needed. Thank you to Health ISAC for the opportunity to make this presentation. Note that we have a case study for a multinational pharmacy retailer available to accompany this presentation. And if you're at the summit in person, please make sure to stop by our sponsor booth, speak to my colleagues there, and pick up a copy of the case study from the people at the booth. If you have questions about data analytics and preserving data privacy in the cloud, then please contact me at phil.sewell@microfocus.com or visit us at cyberres.com. Thank you, and healthy wishes to all.